Good evening. Good evening. Yes, Neeraj.
So I have sent a question in group chat.
Yeah. So till now
Did
I
you
did not
observe?
see the answer. Did not verify the answer. So I will check it. Okay. So tomorrow I will let you know. Is it okay?
Okay, sir. Okay, sir.
Yeah. So you got that answer from which book?
No, sir. I myself checked the dimension of the equation for the calculation of torque, and I
Okay. Okay.
uh, tried example of lecture 3, and the answer
Okay.
came wrong. So I just notified you that it should be
Okay.
corrected as soon as
So
possible.
yes. So tomorrow I will let you know. So today I will check. Cross verify that equation. Correct. Yeah. Okay. So, good evening, students. So, today we have 10th class. So, my slide is visible to everyone?
Yes, sir.
Yeah. Yeah. Okay. So, today is a 10th class and unit number 3, that is a battery energy storage system. So, in the previous class, we discussed the introduction of the battery. So, what is a battery? So, fundamental of the battery, and then we discussed the various type of battery parameters, as well as the equivalent electrical circuit of the battery. So in the previous class, that was the very good because you asked the many question. So that's why I said it is a very good. It was very good class. So today we are going to discuss the functionality of the BMS, that is a battery management system. Then battery pack sensing, there is a current, voltage and temperature, and isolation and thermal control. So today we are going to discuss the basic about the BMS. So what is a battery management system? Before going to next topic, in the last class, student asked many question, and for many questions, so I told in the previous class we will discuss in the next class. So today we are going to discuss the three questions so which you asked in the previous class. First one, how to measure the instantaneous SOC of the battery. Correct. So one of the student asked this question: how we can measure the instantaneous SOC of the battery? So before going to SOC, just revise because in the previous class already discussed the SOC. SOC is a represent the remaining capacity of the battery. So how much percentage of the battery have energy? Correct. So remaining capacity of the battery at given the moment. Correct, because that is an instantaneous SOC. So particular moment, how much energy store is there, and that is a represent is a that is a express as a percentage form. So we can say SOC is a ratio of the remaining capacity divided by the maximum capacity. So we can say in the numerator term that is a remaining capacity, a denominator term that is a maximum capacity into 100. Why 100? Because we are saying SOC that is always in the percentage. That's why it is a 100%. That's why we can multiply 100. So formula number one, that is the most important to measure the SOC. So we can say the remaining capacity upon the maximum capacity. Then we can measure the instantaneous SOC. So measuring of the instantaneous SOC, it is a challenging part because there is a chemical process. So it is a very challenging part, and it is a very risky because battery does not have the direct fuel gauge. So we don't have any direct meter. So we can say we have a voltmeter to measure the voltage. We have a meter to measure the current. We have a rheostat to measure the resistor. But to measure the SOC, state of charge, we don't have any device. We don't have any meter. So we can directly measure the SOC. So we have to measure the some parameter, maybe the battery voltage, battery current, and then we can say now our SOC is at this percent. Correct. So instead of the SOC, it is estimated using the combination of the electrical measurement, models, and the algorithm. So we have to measure the various type of parameters, and then we can estimate the SOC. So straightforward answer is we cannot directly measure the instantaneous SOC. Instead of the instantaneous SOC, we can measure the some electrical parameter, maybe the voltage, maybe the current, and then we can apply the algorithm and then we can measure the SOC. Now question is which type of algorithm we have to use to measure the instantaneous SOC. So measure the instantaneous SOC, we have a various type of algorithm. Otherwise, we can say the various type of method. First one, that is a open circuit voltage method. So we have to measure the open circuit voltage. So measure the battery voltage when no current is flowing. There is a battery is at rest state, correct? So suppose you are not using the your mobile phone, and then we can measure the open circuit voltage, and that is a open circuit voltage method. But normally this method is no more used because every time we are using our mobile, every time we are using our laptop charger battery, and then we can say now we can put our battery in the charging mode, still we are going to check the instantaneous SOC, correct? So that's why this method is no more used. There is an open circuit voltage method, no more use, because we have to disconnect our battery from the load because there is an open circuit voltage. Okay, there is a first method. Second method, that is a Coulomb counting method, otherwise the age counting, ampere hours counting. So Coulomb counting method. So track the current in and out over the time using the current sensor. Correct. So we have to measure the current, and we have to check the how much current is incoming and how much current is outgoing, and then we can say yes, our battery life is maybe the sorry battery efficiency, that battery SOC SOC is maybe the 20%, maybe the 40%, maybe the 100%, correct, by measuring the current. Third method, that is an instantaneous impedance model based estimation. So we have to measure the impedance, otherwise the model based estimation. Use the battery equivalent circuit model, example maybe the Thevenin or RC model, and estimate the SOC from the voltage, current, and model parameters. Correct. Model parameters, maybe the temperature model parameter, maybe the chemical model parameters. Okay. Fourth one, that is a Kalman filter base. So in the previous class, one of the student asked question, we can measure the SOC based on the Kalman filter base method. Yes, we can measure the SOC based on the Kalman filter method. So in advanced algorithm that combine the Coulomb counting method, model, and voltage feedback. So these three method we can combine in the Kalman filter based estimation. Yes, we will get the accurate result, but complexity is large. Yes, suppose you want to get the accurate result, obvious, then we have to face with the complexity. Okay. And final one, that is a latest technology, machine learning and neural network model. Correct? Yes, I think Sabine is working on the neural network and machine learning based approach for the SOC measurement, if I am not wrong, because one of the students discussed with me. So he want to implement, he want to check the like SOC by the machine learning. Maybe the Sabine, yeah, maybe the another student. Correct? I forgot the name, but one of the student working on the SOC for the advanced level technology. So there is a machine level machine learning in AI trained using the battery test data to predict the SOC from the voltage, current, and temperature, etc. Correct. So these five type of algorithm we have to use to measure the instantaneous SOC of the battery. Now I hope you clear about this question. Yes, now you got the answer. So still you have a confusion, then please let me know, because I don't know who asked the question. Maybe the Neeraj, yeah, maybe the Sabine, yeah, maybe the other student. Neeraj, you asked this question, yeah, maybe the some other student.
No, sir, I did not, sir.
Yeah, so I don't know so who asked the question, but I hope now he or she understood about the how we can measure the instantaneous SOC.
So should
Now,
we have to measure instantaneous SOC in our lecture classes? Is it important?
sorry.
Should we have to learn these methods, sir? Kalman filter list method
No,
and
no,
other
no, no.
methods
This is for your
for
just
our
information. No,
course?
no, no, no. This is not a part of the syllabus. So, because one of the student asked this question, so that's why I prepared this lecture notes. Correct. So, but this is not the part of the syllabus. Okay. Next question. Is it possible we can use the multiple electrode in the cell? So before going to discuss about the proper answer, so just revise the what is a electrode in the battery cell. In the battery cell, electrodes are the conducting materials that allow the electrons to enter or leave the electrochemical system. So this is the part of the syllabus, correct? So in the previous class, we discussed about the electrode, correct? Positive anode and cathode. So this slide, it is a part of the syllabus. So electrode is a simple conducting material that allow electrons to enter or leave the electrochemical system. They are essential sites for the redox reaction. So anode, that is a negative, in the previous class we discussed, where oxidation occurs, loss of the electrons, release the electrons to the external circuit, and in discharge mode electrons flow from the anode to cathode. So in the previous class we already discussed. So today I'm again revise this concept. Then cathode, generally we can say the positive electrode, where reduction occur and gain of the electron and receive the electrons from the external circuit. So we can say normally in the cell we have a two electrode, that is a positive and negative, otherwise we can say the cathode and anode. So question was, can battery cell have more than two electrodes? So in the previous class one of the student asked this question, can a battery cell have more than two electrons? So answer is yes. Some of the battery cell have a more than two electrodes. Example, yes. So slide number nine. Yes, but with the condition, it is possible, but with the condition. Condition is in conventional battery cell, a standard battery cell has two electrode, one anode and one cathode, and that is a standard battery cell. In advanced and specialized system, it is possible to have more than two electrode in the single electrochemical unit. These are called the multi-electrode system. So answer is a yes, but it is a with some condition, and that is a advanced and specialized system we can say, and these are called the multi-electrode system. In which type of cell that available? So we can say example of multiple electrode cell, type and description. So bipolar batteries, so we can say the bipolar batteries, multiple anode and cathode layers connected internally in the series. Yes, in the previous class one of the student said, suppose we want to increase the current of the cell, then we have to connect the multiple electrode. Yes, he was correct. So we can use the like multiple electrode in the single cell, but with the special cases, correct? And that is a bipolar batteries. Dual ion batteries, another type, that is a dual ion battery. Both the anodes and the cation are the involved, may include the intermediate electrodes, correct? So there is a anode and cathode. So this is a spelling mistake, anode and cathode, correct? Anode and cathode are involved, may include the intermediate electrons. Okay, so this is the anode and this is a cathode. Okay, so typo mistake. Flow batteries, that is a redox flow. Okay, so another type, that is a flow battery, otherwise a redox flow, may use the membrane separator multiple electrodes compartments. Supercapacitor hybrid cell, maybe you heard about the name, there is a supercapacitor and it is also part of the syllabus. Some hybrid energy systems use the more than two electrodes for the higher efficiency. Okay, so this is the answer for the more than two electrodes use, yeah, no, correct? So answer is a yes. We have a different type of cells available in the market. With a special condition, we can use the multiple electrodes in the battery cell. Okay.
Excuse me, sir.
Yes.
This is for the lithium and battery only, or for other battery also, sir? Other
Other
type
battery
of battery.
also. I am not sure about the lead acid battery, but apart from the lead acid battery, every battery can use for the more than two electrodes in the single cell.
Okay, sir.
And this is the not for particular the lithium ion battery. Okay, but lead acid battery no more use, so that's why I'm not sure about the lead acid battery. Is it possible for the more than two electrodes in the lead acid battery? Correct.
Yes,
Otherwise,
sir.
yes.
Yeah, lead acid batteries have also, sir, multi-electrode system. Just 10 years, 15 years ago,
Okay.
I was tested, and a number of multiple number of electrodes internally connected, and I have worked in that time, sir.
Okay. Okay. So that is also possible, correct, in lead acid battery.
Yes, sir.
Yes, yes, sir. Because nowadays there is a lead acid battery is no more used, correct? In some application may be used. Otherwise, normally lithium ion battery used in the in the maybe the mobile phone as well as the laptop charger as well as the electric vehicle. So majority battery there is a lithium ion batteries. That's why. So you work before the 10 days, 10 years, correct?
Yeah, yeah, 10 years ago, sir.
Yeah, before the 10 years ago. So now maybe that replaced by the lithium ion battery because
Yeah,
lead
yeah.
acid batteries efficiency is very less compared to the lithium ion batteries. Yeah.
For
So
telecom applications, we are using VRLA battery still now, sir.
where which application?
Yes,
Telecom,
sir.
Telecom.
yes, sir.
Yeah, maybe that is a government sector, correct?
Yes, sir.
So maybe they are using because of they want to reduce the price because lead acid battery price is less compared to lithium ion battery, and they don't
Yes,
want to change the system entire system because that battery pack is very large, correct?
yes, sir.
So that's why they don't want to change because battery life is maybe the 10 to 15 years. So they don't want to change the battery. So that's why maybe they don't change. Otherwise, lead acid battery life is efficiency is very less. And even I don't know, maybe the life is maybe the 5 to 7 years only. I am not sure about the lead acid battery. Since how many years they are using? Any idea?
Uh, some batteries lasted for over 20 years, sir.
20 years.
Yes, sir.
So still they are getting like good efficiency.
No, about 40, above 40% efficiency, sir.
Yeah, so that's why,
But
na, because
efficiency no.
normally life of the battery there is like 7 to 8 years.
Yes, sir.
After that, that is
New batteries are like 5 to 6 years, sir. But
yes,
some of the old batteries are working for over 20 years.
over 20 years with efficiency. How much efficiency?
40% about, sir.
Yeah, 40 to 45%, correct? Because
Yes, sir.
new battery efficiency is around like 90%, correct?
Yes, sir.
So there is a 50% reduction of the battery life. But sometime what company will do, so they don't want to change the overall system. Suppose they are satisfied with the 50% efficiency, then it's okay. And sometime industry don't satisfy with the 50% efficiency, so they want to replace that old battery and put the new battery. Suppose you want to replace that old battery, then we have to spend some amount, correct? So
Yes,
some
sir.
company they are considering like we can work with a 50% efficiency, that is okay. Then they are working. Okay.
Okay, sir.
Yeah. So I hope this question also answer is also satisfied with you. Uh, Next question: how to decide the C rate of the battery? So I got this answer from the like many books as well as the research paper. So straightforward answer is this is a very complicated. So decide the C rate that is a very complicated because that is a depend on the manufacturing and there is a R&D work. So the C rate or discharge and charge and discharge rate of the battery is a measure of the how fast battery is charged and discharged relatively to it is a nominal capacity. So in the last class we already understood. So what is a C rate? So now Just revision. So C rate is simple. It is a charge and discharge rate. Okay. So what is a C rate? C rate indicate the current in the amperes at which battery is charged or discharged. It is expressed as the multiple of the battery rated capacity. Okay. But how we can decide the C rate? So C rate formula is I equal to C into C rate. So where I is a charge or discharge current in ampere, and C is a battery capacity, and C rate, there is a rate of a rate multiplier, there is a 1C, 5.5C, 2C. In the previous class, we already discussed 1C there is a fast charging, 0.5C there is a less charging, 2C is a fast charging. Okay, so 1C, 2C, 3C, 5C there is a fast charger. Okay, zero point 0.5, zero point 0.2, zero point 0.3 there is a less charging. So formula for the C rate, there is I equal to C into C rate. Okay, but how we can decide the C rate? Okay, so C rate, there is a 1C current ampere, 2 current rating, there is a 2 ampere. Description, there is a full charge and discharge in the 1 hours. 0.5C, suppose current rating is 1 ampere, so charge and discharge in the 2 hours. So 2C, there is a 4 ampere current rating, charge and discharge in the 30 minutes. 5C, 10 ampere current, charge and discharge in the 12 minutes. So whenever you are increasing the C rate, so you will get the fast charging, correct? So that is a fundamental concept. Okay, but suppose you want to measure the C rate, so we have to measure the multiple parameter. Multiple parameter means we have to measure the current, we have to measure the voltage, we have to measure the thermal rating, we have to
Sir,
measure, we have, yes, 1 minute, we have to measure the like temperature, we have to measure the chemical property. So this all parameter we have to measure with multiple time with the same battery and same environment, then we have to decide the C rate of the battery. Okay, so there is a not directly thumb and rule process to measure the C rate of the battery. So we have to measure the multiple parameters. Yes.
sir, in case of C rate of 5C and the current drawn 10 ampere, the charge discharge is 12 minutes. But I don't understand how the 12 minutes, how 12 minutes is calculated.
So in the last class we discussed, correct? So C rate, how we can decide the C rate. So your current
It,
rating is 10 ampere, correct? So we can say per ampere per hours, so that is a consume the 10 ampere, correct?
yes,
So
sir.
there is a charge, yeah, discharge. So there is a 5C, so 5 times there is a like we can take the charge and discharge. So that's why
It will not come 12 ampere, I think. It's 12 minutes, sir. It may maybe 30 minutes in last
uh,
case.
30.
Yes, sir.
That's
Why
60
30?
divided by 5.
How
5C means 60 divided by 5.
60 divided by 5,
Yes, sir.
correct?
Yes.
For 4
Oh, this
ampere,
is
30 minutes. That means 60 divided by 2. That's 30 minutes.
okay, sir. I got it.
Okay.
Yes, na 60 divided by 5, so there is a 12, correct?
Okay, sir. Okay.
Yeah, and we will do also more numerical on the C rate as well as the SOC, correct? So first you try to understand the what is a C rate, what is a SOC, what is the depth of discharge, and in the one class I will take the more numerical. So you will understand, you will get the more understanding about the like C rate and battery parameters, correct? Yeah. So now clear. So in the previous class, you asked these 3 questions, and another question I already answered. So now any confusion, any query, any confusion? Okay. Yeah. So now we can start the new topic. There is a battery management system, BMS, and there is a most important topics for the syllabus, for the commercialize, for the research, anywhere. Practical application for the electric vehicle, because nowadays battery management system, there is a hot topic. How we can manage the battery in the electric vehicle. So battery management system is the intelligence brain of any battery powered application. So we can say it is a heart of the battery. Okay, there is a battery management system, especially in the electric vehicles, hybrid vehicles, solar system, and UPS system. Correct. So wherever battery we can use BMS, that is a heart of the battery. Okay, it is a primary role is to ensure the safe, efficient, and the reliable operation of the battery pack. Okay, so what is the role of the BMS? BMS is nothing but it is a check the overall safety, overall efficiency, overall reliability. So whatever parameters are there, BMS will check. Okay, maybe the SOC, maybe the depth of discharge, every parameter BMS will calculate, correct, and BMS will manage. There is a simple battery management system. Key function of the BMS. So what is the functions of the BMS? First one is a monitor. So we have to monitor parameters. So which type of parameter you have to monitor? Voltage, current, and temperature, because these three parameters are most important. We have to monitor the voltage, so measure the cell and pack voltage. So maybe the in the battery pack, maybe the 32 cell in the series and 64 cell in the parallel. So we have to measure the every cell voltage and current as well as the battery pack voltage, correct. Current similar for the cell current and the battery current, correct. Temperature, every cell temperature as well as the battery pack temperature. Okay, so we have to check that is a like overheating, yeah, what. So we have to prevent the overheating, correct. Otherwise your vehicle is blast. Sometime we heard about the Ola vehicle is blast. I don't know, maybe in the Nepal you heard, because in the India many Ola vehicles blast in the beginning of the electric vehicle. I don't know. Anybody heard about the others? Anybody seen that is electric vehicle is overheating and
Yes,
battery
sir.
is blast?
Recently, sir, in Biratnagar,
Uh-huh.
one EV car get destroyed due to fire caught due to overheating. Because in Tarai regions in Nepal, temperature reaches maximum to 40 to 43 degrees centigrade, and that occurred 2 3 months ago.
Yeah. So that is a two wheeler. Yeah, three wheeler,
Four wheeler, sir.
four wheeler.
Yeah.
Okay, okay. Because four wheeler is very less in the India, but two wheeler is very high, and that is a two wheeler for the particular for the Ola, correct. But a four wheeler is a very rare case. Suppose that is a parking in the like maybe the full hot area, and there is a drive maybe the since last since last 5 to 6 hours, and they suddenly park in the very hot area, then it is a very dangerous. Then we can say now it's overheating, and then it is like out of control, correct. So main reason is overheating because of the very continuous driving, maybe the 500 and 600 kilometers, and then you park your vehicle in the very hot area, correct, and then it's a fully chance to overheating. Okay, so there is a monitor, and we have to also monitor the state estimation. There is a state of charge, state of health, and state of power. So there is a monitoring, there is a one of the function. Second function, there is a protection. Protect the battery from the dangerous conditions such as the over voltage and under voltage per cell, over current during the charge and discharge, over temperature and under temperature, short circuit and cell imbalance. So cell balance and unbalance, that is the most important in the battery pack. So while design the battery pack, we have to see all the cell, whatever cell, how many cell use in the battery pack, all the cell, that is a balanced condition. It is not like that one cell is fully discharged, another cell is a fully charged. It is not like that. All cell must be the same condition. Maybe the 50% all cell discharge, maybe the 50% all cell is a charge. It is the same condition. It is a not like said, not like that. Maybe then the battery pack, maybe the 30 cell, and out of 30 cell, maybe the 10 cell is a fully charged and 10 cell is a fully discharged. It is not like that. All cell must be the same condition. Okay, so that's why we can say it is a protection. Balancing, cell balancing, ensure all the battery cell in pack are balanced. There is the same voltage and same level charger, as I said in the previous slide. Okay, so improving the performance and lifespan. So we can say the passive balancing, dissipate the exit the energy from the higher charge cell as heat. And second one, we can say the active balancing, transfer the charge from the high to low cell using the converters or the switching circuit. Okay, so we can say the active and passive balancing. That is a simple. Okay, so there is a balancing cell. Fourth one, there is a charging control. Communicate with the charger to control the charging current and voltage. So we have a different type of charger, correct? So we can say the 2-pin, 3-pin, fast charger, slow charger. Many different company use the different charger. But in India, central government decided all the electric vehicle make the standard charger, correct? So suppose in the three wheelers, so all the three wheelers manufacturer has to charge like standard charger. So any industry vehicle can charge from the any charger. I don't know in the Nepal, even Nepal, I think same process, correct? Otherwise, what happens? Suppose I have a different type of vehicle and different type of charger, then I am not able to charge our vehicle, correct? So it is not like that. Okay, so that's why government decide to make the same charger, and there is a standard charger for the two wheeler and three wheeler and the four wheeler, correct? So suppose you have four wheeler, so you can charge from the any charger of the four wheeler, correct? Ensure the safe and efficiency charging, including the fast charging support. Okay, and fifth one, there is a communication interface with the vehicle control unit. There is a VCU, chargers, and the dashboards. Use the protocol like CAN, UART, SMBus, and Modbus. So these are the different type of protocol we will study. So there is a CAN, UART, SMBus. So what is the difference between this type of communication? So we will study in this unit. Okay. So there is a charging protocol. Okay. Data logging and diagnostic. So store the historical data for the voltage, current, temperature, SOC, errors. So every type of data we have to store, and we have to data logging, and we have to diagnostic, correct? Aids in diagnostic, maintenance, and warranty analysis. Seventh parameter is temperature management support. Interface with the cooling and heating system. So we can do in the temperature thermal management support, not the temperature, sorry, thermal management support. Maintains the optimal battery temperature for the safety and the performance. Okay, so that's why we have to manage the thermal management support. But this thermal management support, that is again mechanical part. So summary form, we can say functionality of the battery management. We have to manage the monitoring, we have to manage the protection, balancing, charging control, communication, diagnostic, and thermal control. Okay, so these are the functionality of the battery management system. Is there any confusion? Still now any confusion? Okay. So how look like BMS? So battery management system, so you can see this figure. So from the left hand side, so this is the battery cell and battery pack, and battery pack is nothing but combination of the cell. So you can see cell 1 up to cell n, and that is your series and parallel combination, and then we can say it is a battery pack. Then we have a thermal 1, thermal 2, current, voltage, and voltage n. Correct? So there is a depend on the how many cells are connected and how many cells in the series and parallel combination. And then based on this combination, you have to measure the temperatures. Then we can say the thermal 1, thermal 2. There is a depend on the battery pack. Okay. And this one is a measurement, so we have to measure all the parameters. Okay, after the measurement, there is a capability of the estimation, state of charge, state of health, thermal management, and then this is the controller part. Okay, so every parameter, whatever parameter you are measure, that parameter there is a controllable. So that's how we can use the CAN bus. So any type of bus you can use, correct? So normally we use the CAN bus, okay. And this is the two-way communication because we can control via laptop. So we can say this is the laptop, correct. Every data is coming to laptop, and we can give also laptop from the controller, correct. And maybe get controller, maybe the microcontroller, maybe the FPG, any controller, okay. So this is the overall block diagram of the BMS. So suppose you want to learn more about BMS, so I got this diagram from this link. There is a CS electrical anode anodeelectronics.com. So you can go through this website. So you will see, you will get the more information about the BMS, correct. But most of the information I cover in this lecture notes. So BMS is an electronics system that manage a rechargeable battery by monitoring its state, controlling its environment, and protecting it from the operating outside the safe limit. It is widely used in the electric vehicles, energy storage system, and UPS and industrial battery application. Key objective: ensuring battery life, maximum battery life, enhancing the performance and efficiency, providing the real-time monitoring and diagnostic. Correct. So some of the key objective already I discussed in the previous slide, and some of the objective maybe we will discuss in the next slide. So architecture of the BMS. So what is the architecture of the BMS? So there is a centralized BMS, distributed BMS. So we can say the BMS type, maybe the two type, one is a centralized and one is a distributed. So what is a centralized? Use a single control unit for the all the battery cells. So we can use only one BMS, and there is a centralized BMS. It is a simple design but may have a scalability issue, correct. Suppose you are using the single BMS system for all system, so we can say it is a very complex to say which type of cell is damaged, correct. And that's why normally we use the distributed BMS. Each cell its own dedicated monitoring unit, improve the scalability and the fault tolerance, correct. Yes, we can say suppose we have a like uh, every cell have a different management system, then we can easily identify which cell is damaged, correct. So complexity is high, so we will get like more accuracy. That's why we can say improve the scalability, okay. Modular BMS use the multiple controller, each handling the group of the cell, offers the balance between the centralized and the distributed architecture. That is the modular BMS. Components of BMS. So how many components we can use? So typically BMS consists of the battery management controller, that is a BMC, the brains of the BMS processing real-time data. So BMC, obvious, that is a controller part. So we can say it is a brain of the BMS. Voltage and current sensor measure the cell voltage and the current. Temperature sensor monitoring the heat variation. Balancing circuit ensure the uniform charge distribution. So every cell have the uniform charging and discharging. Bit power supply unit provide the energy to BMS components. Communication interface facilitate data exchange with the external system. So these are the major components for the battery management system. So first one, there is a BMC, there is a battery management controller. Second one, there is a voltage and current sensor. Third one, there is a temperature sensor. Fourth one, there is a balancing circuit. Fifth one, there is a power supply unit. And sixth one, there is a communication interface. So these are the major components of the BMS. Design consideration of the BMS. So what type of parameter we have to consider for the design? So there is a battery chemistry compatibility. So which type of chemistry, which type of chemical you use for the battery, correct? BMS must be designed for the specific battery chemistry such as lithium ion that is a commonly used, lead acid, nickel metal, yeah, any other chemical material. So that is a first component we have to consider. Power consumption. An efficient BMS should consume minimal power to prevent the draining the battery unnecessary. Correct. So we have to check also power consumption. Then third one, that is a scalability for large scale application, maybe the electric vehicle, maybe the grid storage. Scalable BMS is the essential. So we have to check the scalability, correct? Redundancy and fault tolerance. To enhance the reliability, redundancy in the monitoring circuit is a critical part. Environmental condition, as I said in the previous class, suppose you want to use your battery in the very cold area, so we have to design the battery as per the environment condition, correct? So environmental condition is the most important. BMS design must account for the temperature, humidity and the vibration control, correct? So we have to consider all the parameters. Challenges. So what type of challenges you are faced while design the BMS? So accuracy of the SOC and SOH estimation. So how much accuracy we will get to measure the SOC and SOH? SOC and SOH estimation technique required the precise algorithm and data calibration. That is our most important parameter. Thermal runaway prevention. Lithium ion batteries pose the risk thermal runaway. Necessity robust thermal management. So we have to provide the robust thermal management system. Cost constant. Advanced BMS solution with active balancing and sophisticated fault detection can be expensive. Yes, suppose you want more and more accurate battery management system, then we have to compromise with the cost, correct? So cost constant, it is also challenges. Integrating integration with a smart grid and IoT, because nowadays people talk about the smart grid, microgrid, nano grid, correct? V2G technology, G2V technology. So integration with the smart grid and IoT. Modern BMS must be compatible with the IoT and smart energy grid for data analytic and predictive maintenance. So these are the challenges in the BMS. What are the future trends? So future trends, AI and machine learning. AI-based BMS can predict the battery failures, optimize the charging cycles, and enhance the battery longevity. Correct? So
Sir, what
yes,
is
yes.
IoT, sir? IoT, what is that?
Oh, IoT, Internet of Things. IoT in the previous slide. IoT, yes. Internet of Things. So Internet of Thing is nothing, but we can say, suppose you want to operate your AC from India, correct? Air condition from India. So we can connect our IP servers. So we can say the Internet protocol, IP server, and we can operate your device from anywhere, correct? So IP server is connected with a satellite, and through satellite we can operate our any gadget of our home. So nowadays many people use the like all the gadget they want to operate from mobile, they want to operate from any location. Suppose I want to operate any device from India to maybe the USA, I can operate. I have to connect one IP address to our device, and that is the Internet of Things. And that is a like smart device. Nowadays, people want a like smart device, and that all the smart device that is a connect with the Internet of Things. Got it? Got it now?
Sir, yes.
Okay. Wireless BMS, second future planning and future trend, that is a wireless BMS. Eliminate the complex wiring, because suppose you are connecting the like multiple wire. So first thing you are add the register, because every wire have an internal register. Second thing you are adding the like I square R losses. Second one, there is a system is complex, you are adding the weight. So that's why people are going to use the wireless communication and wireless BMS, reducing weight and improving the reliability in the EVS. Correct? Solid state battery management. With solid state battery emerging, BMS need to adapt the new monitoring technique, because in the future lithium ion battery that is replaced with the solid state battery. Okay, nowadays maybe the some company use the solid state battery, but in the future maybe the all the company use the solid state battery. Okay, so there is a third one, and fourth one, there is a blockchain of the battery data security. Okay, so normally we can use for the safety, so nobody will track our data. So blockchain technology can secure the battery data, enabling the transparent tracking of the battery use in the life cycle. Otherwise, what happen? Suppose you want to charge your vehicle and somebody hack your battery, correct? So maybe there is a overcharging, over voltage. So we cannot control our side, correct? So somebody, suppose simple example, somebody hack your laptop, correct? So you cannot control your laptop by yourself. Somebody can handle your laptop, whatever whoever hack your laptop, correct? So same, there is a blockchain technology, so we can use the blockchain technology. That's why nobody can hack our system. So that is your future planning. Yes, so this is the future trends of the BMS. So key point from the today's class. So there is a functionality of the BMS. In the functionality of the BMS, we seen architecture of the BMS, major components of the BMS, as well as the challenges of the BMS, as well as the future trends of the BMS. So these are the key points of the today's class. In the next class, we will discuss the battery pack sensing. There is a current, voltage, and temperature. So how we can sense this parameter, and which type of sensor we can use, as well as the isolation and thermal control. So in the next class, we will discuss on this topic. These are the references which I used to prepare my lecture notes. Thank you so much for your attention. If you have any question, then please let me know so we can discuss. Yes, is there any confusion? In the last lecture, you asked the many question. If you have any confusion, please let me know so we can discuss in the class, and after that we can wind up. Yes, any confusion, any query? Okay, no confusion, then we will take the new topic in the next class, and that is a tomorrow class. And please submit your lab experiment number 1. If you have any confusion in the lab experiment, then please let me know. Okay, so we can discuss. So is there any confusion? Is there any query? You are facing any issue for the experiment number 1? So
Uh, excuse me, sir.
yes, yes, okay.
How to measure the torque, sir, in the Simulink?
Measure the torque.
Yes, sir.
So you can measure the power and the speed. So torque is the nothing but product of the power and the speed.
We can measure. We can use any kind of sensor, sir, for that.
As per my knowledge, in the for 2000 till 2024 MOET model, there is no any torque meter. But I am not sure in the 2025 version. So you are using which version in MATLAB?
2024, sir.
No. So in the 2024, I am also using the 2024. There is a not torque meter. We have a current meter, we have a voltage meter, but we don't have a torque meter.
So we just multiply speed and power for the torque, sir.
Yes.
Okay, sir. Thank you, sir.
Yeah. Is
And
there any
excuse
confusion?
me, sir.
Yes.
For the
Yes.
power flow, we just need to measure the current and voltage of the battery, sir.
Yes. Yes. Normally we can measure the voltage and current, correct? So you
Yes,
can
sir.
just multiply the voltage and current, and that is your power. and we are also measuring the speed, correct?
Yes, sir.
So then you can multiply, and then we will get the like torque.
Okay, okay, sir. Thank you, sir.
Okay. So how many students submitted? Any idea? I got the one response, but I don't know. Let me check.
I have completed the simulation, sir.
Yes.
But I was a bit confused to prepare the report
So
about the torque.
in the first semester, you already prepared, correct? Lab record.
No, no, not about the report, sir. I was confused how to get the torque for the report.
Okay, okay, okay. So now you got it, correct?
Yes, sir, yes.
Yeah. So I got only one response from the Neeraj. So Neeraj already submitted. So I will check. Yeah. Okay.
Okay,
And
sir.
you also please maintain the record. Okay. Like Word file as well as the PDF file.
Okay, sir.
Okay. Okay, so another student, I hope in the next week they will submit. Not next week, end of this week, because today is a Tuesday. So maybe the end of this week. So maybe the up to Sunday, you have to submit. Correct? Because I given the deadline that is a 27. Then you requested to please consider the like it will take time. So that's why I give the new deadline, and that is a 2nd June, 2nd July. Still I can extend, and there is a Sunday. Up to Sunday you can submit your lab record. Okay. Okay, if you no question, then we can close the today's class.